Practice test. 11 methods. Find the slope of the line. Question 1a. Let's add 9y to both sides. Okay. You don't have to write that. Now, if I want to find the slope, I must have single y, right? The slope's coming out nice and easily if we get our line into this form, and there's the gradient number. So answer the question, slope equals 7/9. Now, book also says if you're in general form of a straight line, there the slope has to equal minus a on b. For us, that is, there's my a, 7. There's my b, minus 9. But it's a minus a, so I get 7/9. Tick, right? If you're doing it this way, you still want to show a bit of working out, right? Okay, next one. Let's scroll down. Find the equation of the straight line through this point. X is 3, y is minus 2, which is perpendicular to the line in part A. Right, the gradient in part A was 7/9. The perpendicular gradient is minus 9 on 7. So we are flipping the 7/9 and we are whacking on a minus. Perpendicular, make sure you read the question carefully. Right, so I could say using this point, I'll do it the way I like to do it, which is basically just to think about what that gradient equals. And gradient equals a change in y over a change in x. And I'm going to use that point. So I'm going to say a change from this point has to equal that gradient. Right, that's going to take me to this next step. Y plus 2 equals, I'm going to multiply both sides by x minus 3, minus 9 on 7, x minus 3. We're going to get minus 9 on 7x minus, plus, what's 3 times 9? 27. Right, just careful with negatives, minus times minus, plus, and then you've got a minus 2. Now that minus 2, let's call it 14/7. Right, so I can do the subtraction there easily. Minus 9 on 7x plus 13 on 7. Okay. Now, here's the other way. Try and do it quickly. I know that equations of straight lines take on this form. I plug in the gradient. These methods are really not that different. Then I use the point. I say that this equation has to give this point, therefore minus 2 equals minus 9 on 7 times 3 plus some number, I'm not sure what it is yet, about to find out. Minus 2 equals minus 27 on 7 plus some number. We need to add 27 on 7 to both sides. So there, say therefore, I get 27 on 7 plus, that's a minus, sorry, minus 14 on 7. So I've changed the 2. I think you can see what I'm doing here. I work out my C, I put it all together. Make sure you answer the question and give the full equation of the line at the end. Right. Okay. Next. By the way, these videos will just go one at a time. Does the point 7, 7 lie on the line? Question 1a. So I better write this down. 7x minus 9y plus 11 equals 0. And in the rearranged form, if I want to use that, 7 on 9x plus 11. Okay. So what I need to now figure out is if I was to put a 7, an x is 7, into this equation, do I get a y of 7? Or, using the general form, if I make the x and the y 7, does it really equal 0? If it equals something else, this point does not lie on the line. Maybe it's easier to use general form. So we could say sub, as in substitute, into equation minus 9 times 7, that's a 9. This pen's a bit tricky. And we find out what it equals. If it equals 0, the point's on the line. Looks like it won't, because there's a difference there of 2 7s. It's 7 and 7, that's 9. So here we are at minus 14, and you're plusing 11, you get minus 3. Doesn't work. So answer the question properly. No. Point not on line. Okay. Right. I wanted to show you this. I think it's in my calculator at the moment. Checking on a calculator. Y equals 7 on 9x plus 11. Graph that. It's going off scale. What? X is 7, y is 7. Clearly not on the line, right? If I want to see, I'm going to need more y's. Maybe we'll go up to 20. So I've just pressed window to change what I'm viewing there. If I then do second calc value, make the x 7, see what the value actually is. And it's 16 and 4/9, so it's way off. 7, 7. Right, so that all agrees with my working, and I've done that to remind you to use your calculator in this test, even if you're just using it as a check like I just did then. Find the equation of the line through these points. I need a gradient. Gradient equals change in y on change in x. It's 13 minus minus 3, that's a 16, and it's minus 2 minus minus 5. What's the minuses? We get 16 on 3. Minus 2 plus 5 is 3. Right, using the gradient and a point. Maybe I say I'm going to use maybe this point, the numbers are a bit smaller. It doesn't matter. I would say change in y, minus minus makes plus, change in x has to give this gradient. Right. Then y equals times both sides by x plus 5. Subtract 3 from both sides. Tidy up. Now what have we got here? 5 16s are 80. 80 on 3 minus 9 on 3 gives quite a large number. Anyway, 71 on 3. So y equals 16 on 3x plus, which should have been there, sorry, plus 71 on 3. Using the other point will not change anything. Or it shouldn't. If it does, something's wrong. Using this point, change in y, change in x equals 16 on 3. Right? Therefore, y equals 16 on 3x plus 2 16 on 3's. So I'm multiplying both sides by this, x plus 2. That's 32 on 3. That 13's got to come over. Plus 13, that's the same as 39 on 3. Y equals 16 on 3x plus 32 plus 39 is 71. Same answer I got in the other one. And again, I did it before, so I won't do it again, but you could have done this. Could have said y equals 16 on 3x plus some number. Could have used a point to find what that number was. All right. Now, is that the end of page 1? Let's have a look. Yes, I'll pause the video there, unless this is a follow-on. Find where the line meets. Oh, actually, I better do this one so they follow on from each other. So we had, let's write the equation. The equation we've just worked out, y equals 16 on 3x. It was plus 71 on 3, I believe. Okay. Where does that meet? This equation, I might actually number them. That's equation 1, this is equation 2. Now, equation 2, rearranging, I could write y equals 2/3 x. Right, so we need to add 2x to both sides, but then we have to divide it by 3, minus, what's 12 divided 3? 4. Right. So basically what's happening is that I can say where those equations meet, the x's and the y's are the same in each equation. In each equation, they're set up the same way to say a y equals this, a y equals this, right? Both that expression there and this expression here, the 16 on 3x plus 71 on 3, they both have to give the same y value. Okay? So therefore, 2/3 x minus 4 has to equal 16 on 3x plus 71 on 3. Okay, let's go for positive x values. So if I take this over and minus it, 14 on 3x, we have to minus from both sides. So minus 4, it's minus 12 on 3, minus 71 on 3. All right. So I'm getting 14 on 3x has to equal 80, was it? Minus 83 on 3, okay, because minus 12 minus another 71 gets me down to minus 83. Let's times both sides by 3. 14x equals 80 minus 83. Therefore, x equals minus 83 on 14. Bit unusual. Right, okay. So let's check it on the calculator as well. Erase everything that I don't want to see on my other screen. That's a 71 on 3. Hopefully this won't obstruct the view. Because again, this is a good one to check on the calculator. So the first equation, I had a 16 on 3x plus 71 on 3. Right. Now the other equation, which I can't see at the moment, 2/3 x minus 4. Let's put that in. 2 on 3 x minus 4. And I'm meeting at quite a low value. So over here, do a calc intersect. First curve, second curve. The guess is over here. So it says minus 7.95. Minus 7.95, and the x is minus 5.93. Right. Right. So the question would be, is my x the same as their x? Minus 83 on 14. Is it the same as minus 5.9? Let's have a look. Minus 83 on 14, wasn't it? Minus 83 on 14. Okay. Minus 83, divide 14. And can you see we got the same value for x? Right, so I'm using the calculator to check that point. So that is good. I can also use the calculator to get the y value. Because where it says find where the line meets, I really should quote the y value as well. It's a little bit annoying, but it is what it is. It'd be nice if it was just x equals 2, but it won't always be that way. So if I know that y equals 2/3 x minus 4, I'm going to go sub x, running out of room, minus 83 on 14 into equation 2. I could say the y is 2/3 times minus 83 on 14 minus 4. We're going to end up being, what's 3 14s? 42. 40 seconds. Let's just write minus 4. I think this is probably something that you could do on your calculator to find this y value. So I get minus 166 on 42 minus 4, which will be, what's that? Minus 440s are 160, minus 168 on 42. I'd get 300 minus 300, this can be simplified, minus 334 on 42. Minus 334 on 42. I reckon this is all calculator time, this stuff. So again, using that calculator, people, can't remember what I said now, minus 334 on 42, minus 334, 42, I think it wasn't at minus 7 point something. Yeah, so that looks right. If you press alpha F1, fraction to decimal, it's down here, F to D. Alright, so there's the fraction at the simplest form. I could have got to that without the calculator. I could have just halved this and this. There's not enough room here, which is a little bit annoying. I just want to write one more thing with this question. So our x value was minus 83 on 14. Our y value is coming out to be this fraction here simplified, so I halve it. 150, what's half of 34 is 17, so it's 167 on 21. Right. Because what I should be doing to answer this question, don't forget the working out, you do need it. Make sure you've got a bit more room on the test. You'd say they meet at this point. Now, some of you might be wanting to ask, could I write those as decimal numbers? I would say yes, you can. If you're writing them as decimals, maybe 3 decimal places is standard, but I wouldn't take any marks off if you'd done that. However, we've got 6 marks here for question 2, right? 6 marks, that's going to be spread out over part A and part B. So if you're just writing this is the answer, you're not getting, I'm guessing maybe that was supposed to be 3 marks. This is supposed to be 3 marks. I would like to see working out, right? So for example, even if you're using the calculator, you've got to rearrange this equation to enter it into your calculator. So at a minimum, you'd need to show that. And you'd need to write statements like this equation is going to equal the equation I had from 2a. And then you could say using GC, these are the points, right? And then I think you could warrant all the marks. Right? Because it didn't say you couldn't use the calculator, and we're trying to encourage you to use it, especially in a test where you're trying to be extra careful. All right, I'll stop it there for part 1.